students, I hope all of you are doing good. Let's start today's chapter, Playing with Numbers, H.C.F and L.C.M. Test for divisibility. We know that composite numbers are divisible by smaller numbers. To see if a number is divisible by another number, normally we perform the actual division. However, in certain cases, we can find out the possibility of division by certain tests. Following are some such tests. Many of them we have studied in earlier classes. Okay, number one is divisibility by 2. A number is divisible by 2 if its unit place is divisible by 2. For example, numbers like these are divisible by 2. Since their units place are divisible by 2, as you can see here in case of 18, 8 is at units place, in case of 20, 0 is at units place, and in case of 56, 6 is at units place. So all these numbers are divisible by 2. Okay. However, numbers like these are not divisible by 2 as their unit plates are not divisible by 2, right? Number 2 is divisibility by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. For example, 183, 435, 177 are divisible by 3 as, see, 183, 1 plus 8 plus 3 is what? 8, 1 plus 8 is 9 plus 3 is 12. 12 is divisible by 3, that means this number is also divisible by 3, right? However, here are some numbers like these are not divisible by 3 as the sum of their digits are not divisible by 3. Have a look, 125, 1 plus 2 plus 5, 1 plus 2 is 3, 3 plus 5 is 8, 8 is it divisible by 3? No, it is not divisible by 3. So, this number is also not divisible by 3, right? Next, divisibility by 4. A number is divisible by 4 if the number formed by digits in tens and units place is divisible by 4, right? For example, this is the digit 3748. So, what will we do? It is divisible by 4 since the digits at tens and units place is divisible by 4. So, what will we do? We will take these two digits which are at units and tens place, that is 48. So, 48 is divisible by 4, that means this number is also divisible by 4. Okay, however, the number, this is not divisible by 4. Number 4, divisibility by 5. A number is divisible by 5 if its units digit is 0 or 5. For example, 15, 70, 95, etc. are divisible by 5, while these numbers are not divisible by 5. Okay. Number 5, divisibility by 6. A number is divisible by 6 if it's divisible by both 3 and 2. For example, let's consider this example 4272, this number. Okay. So, if we do the sum of all the digits, we'll get 15, which is divisible by 3. And also unit place has what? 2. Okay, that means this number is divisible by 6, right? Next, divisibility by 8. A number is divisible by 8 if the number formed by the last 3 digits is divisible by 8. For example, let's consider this number, okay, 712. We'll take this number because we'll take that number which is at units, tens and hundred place, okay. So, here 712 is divisible by 8, that means this number is also divisible by 8, right? Next, divisibility by 9. A number is divisible by 9 if the sum of its digit is divisible by 9. For example, let's consider this number, okay. Sum of digit is what? Sum of digit is 18, which is divisible by 9. That means this number is divisible by 9, okay. Next, divisibility by 10. A number is divisible by 10 if its units digit is 0. This is very simple, okay. See, all these numbers have 0 at units place, that means all these numbers are divisible by 10, while these numbers are not divisible by 10, okay. Next, divisibility by 11. A number is divisible by 11 if the difference of the sum of its digit in odd places and the sum of digits in even places starting from the unit place is either 0 or the multiple of 11. For example, we have this number, okay. Now, 17928. We'll start from the units place, okay. Odd place, then odd place, and this is odd place. Even place digit, and even place digit. Let's do the sum of sum of digits at odd places. Okay, so sum of digits at odd places. Okay, so digits are 8 plus 2 plus 7. 8 plus 2 is 10 plus 7 is equals to 17. Now, sum of digits at even places. What are the digits? 7 plus 9 plus 1. 7 plus 9 is 16 plus 1 is 17. Okay, now we will find the difference of these. Okay, so 17 minus 17 is what? 0. Okay, so this number means this number is divisible by 11. Okay, here is another example also. This, okay, here also this number is also divisible by 11 because the difference of their sums is 0, right? Now, general properties of divisibility. Property number 1. If A, B, C are three natural numbers such that A is divisible by B and B is divisible by C, then A is also divisible by C. Verification. 36 is divisible by 6 and 6 is divisible by 3 and 2. Now, 36 is divisible by 3 and 2 also, right? Property 2. If A and B are two co-prime numbers such that a number C is divisible by both A and B, then C is also divisible by A into B. For example, 35 is divisible by 5 and 7. It is also divisible by 5 into 7 is equals to 35, right? Property 3, if two numbers B and C are divisible by a number A, then B plus C is also divisible by A. Verification, 25 and 45 are both divisible by 5. Their sum, that is 25 plus 45 is equals to 70, is also divisible by 5. Property 4, if two numbers B and C are divisible by number A, then B minus C is also divisible by A. For example, 183 and 654 are divisible by 3 and their difference is 471, which is also divisible by 3. Okay, let's do exercise 6.1. Test the divisibility of the following by 2. Okay, here at unit place we have 0, so it is divisible by 2. Here at unit place it is 5, so it is not divisible by 2 because 5 is not divisible by 2, right? This is also divisible by 2 because at unit place we have 8, okay, and this is also not, it's not also divisible by 2 because it has 7 at unit place and 7, you know, is not divisible by 2, right? Now, highest common factor. The highest common factor of two or more numbers is a number which is the greatest among their common factors. H.C.F is also known as the greatest common divisor. There are two commonly used methods for finding the H.C.F of two or more numbers. They are prime factorization method and the continued division method. Number 1, prime factorization method. To find the H.C.F of two or more numbers by prime factorization, we first find the prime factors of each number and find the highest common factors. Example, we have to find the H.C.F of 144 and 200. Okay. So first what will we do? We will find the prime factors of each number. Okay. So here are the prime factors of 144 and prime factors of 200. Okay. Now, H.C.F of these two numbers is what? 8, right? Now, to find H.C.F by continued division method. In this method, we divide the larger number by the smaller number, we get a remainder. Then we divide the first divisor by the remainder, getting a new remainder. We continue this process till we get 0 as a remainder. The last divisor is the required H.C.F of the given numbers. Okay, for example, we have to find the H.C.F of these two numbers by division method. Okay, so 204 is the greater number, so we will divide this number by 144, right? 144 ones are 144. 0, 10 minus 4 is 6. Now, this is the remainder. Now, this will become the divisor. Okay, and 144 means this divisor will become the dividend. Now, 60 2s are 120. Now, 24 is the remainder. 24 will become the divisor and 60 will become the dividend. 24 2s are 48. Okay. Now, 12 will become the divisor and 24. And you know, 12 2s are 24. Okay. So, what is the H.C.F? H.C.F is 12. Right? So, to find H.C.F of more than two numbers, we proceed as follows. First, find HCF of any two numbers, and 3, 2, we find the HCF of this result and the third number. Okay. For example, let's have a look. We have given 3 numbers, right? We have 120, 144 and 180. Okay, so first we will find the HCF of 120 and 144. Okay, so 120 ones are 120, 24, 120. Okay, 24 5s are 120. Okay, so now we have next number, which is 180. We will divide 180 by which number? We will divide this number by 24. So 24 is equals to 2 into 2 into 2 into 3, and 36, 2 into 2 into 3 into 3. Now let's find out the common factors. Okay, so HCF is what? 2 into 2 into 3. That means 2 2s are 4 and 4 3s are 12. So HCF is 12. Okay. Next is lowest common multiple, that is LCM. The lowest common multiple of 2 or more numbers is a number which is a common multiple of the numbers and is the smallest among all multiples. Okay. For example, let's consider these two numbers, that is 12 and 24. So multiples of 12 are here given and multiples of 24 are these. So the lowest common multiple of both is what? 24. Okay, as you can see here, there are two methods which are usually employed to find the LCM of given numbers. They are prime factorization method and common division method. Okay, let's first talk about prime factorization method. In this method, we find the prime factors of each number and express that in exponential form, that is power of primes. We take the product of each prime factor with the highest power to calculate the LCM. For example, LCM of 40, 48 and 64. Okay, so we will find, what will we do? We will write 40 is equals to 2 into 2 into 2 into 5. So we can write it as like 2 raised to the power 3, okay, into 5. Okay, and then we have 48. So we write 2 into 2 into 2 into 2 into 3. So we will write it as 2 raised to the power 4 into 3. Then we have 64. 2 into 2 into 2 into 2 into 2 into 2. That is 2 raised to the power 6. Okay. So LCM is what? 2 raised to the power 6 into 3 into 5. 2 raised to the power 6 is 64 and 15. 64 into 15 is 960. Okay. Next is common division method. To find LCM of numbers with this method, we adopt the following procedure. Number 1, write all numbers in a row separated by commas. 2, choose the least prime number which divides at least one of the numbers. 3, divide each given number by this prime number and write the quotient below the given numbers in the second row. The numbers which are not divisible by the prime number are carried over to the second row as such. 4, repeat steps 2 and 3 with the second row and form the third row. Continue this process till the numbers in a row are all 1. Okay. And 5, the product of all the prime divisors is the required LCM. For example, we have to find the LCM of 15, 20, 25 and 30. Let's do it. We have to find the LCM by the division method. Okay. So we have 15, 20, 25 and 30. So first we will divide by 2. We cannot divide 15. 15 is not completely divisible by 2. So we will write 15 as it is. 10, we will write 25 as it is, and here 15. Okay. Now 2. 2 5s are 10, 25, 15. Okay. Next we will take a 3. 3 5s are 15. We will write 5 as it is, 25 as it is, and here 5. Now 5 1s are 5, 1s are 5, 5 5s are 25, 5 1s are 5, then 5, 1, 1. Okay, so now the LCM of these number is 2 into 2 into 3 into 5 into 5. 2 into 2, 4, 4 into 3 is 12, and 5 into 5 is 20. 5. Okay, 12 fives are 60, 6 carry, 12 twos are 24 plus 6, 30. So 300 is the LCM of these numbers. Okay. Let's do exercise 6.3. Determine the LCM of numbers in each of the following. 48 and 64. Okay, 48, 2 2s are 4, 2 4s are 8, 2 1s are 2, 2 2s are 12, 2 6 are 12, 2 3s are 6 and 3 1s are 3. So 48 is equals to 2 raised to the power 4 into 3 and 64 is 2 raised to the power 6. Okay, so the LCM is what? 2 raised to the power 6 into 3, that is 64 into 3. 3 4s are 12, 1 carry, 3 6 are 18 plus 1 19. So 192 is the LCM. Okay. Things to remember. Number 1, a number which divides a given number exactly is called a factor of the given number. 2, a multiple of a number is exactly divisible by the number. 3, every number is a factor as well as multiple of itself. 4, 1 is a factor of every number and it is neither prime nor composite. Remember that. Okay. Number 5, 2 is the only even prime number. Okay, other than this number, not other number is prime number, even number. Okay. 6, prime factorization of a number is unique. 7, a number is divisible by 2 if the unit digits of the number is 0, 2, 4, 6 and 8. 3, if the sum of digits is divisible by 3. 4, if the number formed by its tens and units places is divisible by 4. 5, if units digit is 0 or 5. 6, if it is divisible by 2 and 3. 8, if the number formed by its hundreds, tens and units places is divisible by 8. 9, if the sum of digits is divisible by 9. 10, if the units digit is 0. And 11, if the difference of the sum of its digits in odd places and the sum of digits in even places is either 0 or divisible by 11. Okay. Number 8, the H.C.F of 2 or more numbers is the largest number that divides all the given numbers. 9, the L.C.M of 2 or more numbers is the smallest number which is divisible by all the given numbers. 10, the product of H.C.F and L.C.M of two numbers equals their product. This result may not be true for more than 2 numbers. 11, the H.C.F of any 2 prime or co-prime numbers equals to 1. 12, the LCM of any 2 prime or co-prime numbers equals their product. 13, the H.C.F of 2 or more number is never greater than any of the numbers. 14, the LCM of 2 or more numbers is never less than any of the numbers. 15, the H.C.F of 2 or more numbers is a factor of their LCM. And number 16, if x is a factor of y, then the H.C.F of x and y is x and the LCM of x and y is 5. Right, students, I hope you have understood this chapter. Now you will do practice of the remaining questions.